Picture this. You're sitting right outside the exam hall. You've got exactly 20 minutes before your 0478 computer science mock exam starts. You're flipping through your notes and you're feeling totally confident. But what if I told you that on page 3 of that exam paper, you are about to lose critical grade boundaries on a seemingly easy parity check question? Yeah, you know what parity is, but the examiner is still going to give you 0 marks. Why? Because just knowing the basic definition, it's not enough anymore. Stick with me, because we're going to fix that fatal error right now and save your grade. Okay, let's dive into this. Imagine you're in the exam, the clock is ticking, and you see this exact question. Data is transmitted to a robotic arm in a factory. How could a parity check fail to detect an error during transmission? Now, most students absolutely panic here and write something like, it fails if bits flip, or it just checks if ones are even or odd. 0 marks. Why? Well, if you just drop a generic binary definition without actually anchoring it to the robot's transmission data mentioned in the scenario, Cambridge examiners will award you absolutely nothing. They are testing your application, not just your memory.
And honestly, this illustrates the absolute most painful learner mistake in IGCSE computer science. Look at this direct warning from the examiner reports. It explicitly says, generic responses rarely gain full marks. Students lose marks because they do not anchor their explanation to the details provided. See, ordinary revision, just memorizing isolated labels, going through flashcards, reading textbook definitions, it completely falls apart when the mark scheme demands real applied reasoning. You literally cannot just drop the word parity and expect a mark to magically appear.
When we compare isolated theory to applied reasoning, it reveals exactly where things go off the rails. Computer science mistakes happen when students confuse similar concepts instead of diagnosing the exact demand of the question. You see this all the time, mixing up memory versus storage, validation versus verification, or in our case today, just explaining what a parity bit is instead of how it's actively used in the specific context. If you stay on the isolated theory side, you lose marks. We need to shift you over to applied exam connections.
Which brings us to what I like to call the fatal trap, naming without explaining. Guys, this is a massive red flag for examiners. The most common wrong turn I see is just naming a device or a method, like parity check, without sequentially explaining how the process actually works. Saying the system uses parity to find errors is just naming. Explaining that the sender counts the number of 1 bits, adds a parity bit to make the total even, and the receiver recalculates this upon arrival, now that is explaining.
So, how do we actually fix this before you walk into that exam hall? Well, a top-tier revision cycle requires exactly 3 passes to move you from basic recognition to full exam adaptability. 3 passes. Not just skimming your textbook once, highlighting a paragraph, and hoping for the best.
This 3-step cycle builds your ultimate exam defense. Step 1. Secure the definitions. You absolutely need to know what parity is at a baseline level. Step 2. Rehearse worked explanations. You have to practice writing out the exact sequence of how the sender and receiver interact. And step 3, change the scenario and adapt. This right here is the magic step. If you practiced your explanation with a smartphone scenario, change it to an embedded system in a car. Ask yourself, how does your explanation shift? Training your brain to adapt to the scenario is exactly how you prep for those exam day surprises.
Now, before your pen even touches the paper, I need you to pause. Look at the question. What exactly is the task testing? Is it asking for binary manipulation? Is it testing logical reasoning or protocol understanding? You have to pause and predict the examiner's intent. If you don't diagnose the exact demand correctly, you're going to end up dumping everything you know about parity onto the page without any real direction. And trust me, the examiner is not giving you marks for a random brain dump.
Now, in just a second, I'm going to show you the exact examiner clue that transforms a 0-mark definition into a top-band answer. This is the absolute secret to unlocking those final grade boundaries. But first, you need the 4-part framework that makes that clue completely obvious. All right, here it is, the 4-prompt framework. This is a highly reliable memory structure that anchors technical processes to specific real-world consequences. Prompt 1, what is it? Prompt 2, how does it work? Prompt 3, where is it used? And prompt 4, why is it better or worse than an alternative in that specific situation? Listen, if you can confidently answer these 4 prompts out loud for any topic in the 0478 syllabus, you are ready for the exam. Let's see this framework in action. Let's raise the stakes a bit. It's time for an interactive challenge. I want you to spot the error in this scenario.
A school network transmits attendance data using even parity. An error occurs, 2 bits are flipped during transmission, but the system falsely accepts the data as correct. Why? I want you to apply those 4 prompts to this exact Cambridge-style scenario. Think about the sequence of an even parity check and what happens mathematically if 2 bits flip at the exact same time.
And this brilliantly illustrates the gap between an average student and a top band student. Notice the stark difference here. Over on the flawed side, it checks bits for errors, but 2 bits flipped, so doesn't work. That's incredibly vague. You lose the mark. But look at the top band answer. During the school network's attendance data transmission, even parity counts the ones. If 2 bits flip, the total number of ones remains even, so the receiving computer falsely accepts the corrupted attendance data as valid. Do you see the specific context, the exact logical sequence? That is exactly how you win the marks.
Imagine I'm the examiner right now, sitting at my desk with a red pen correcting your mock paper. I'm using this exact checklist. First, I'm looking to convert your vague wording into precise terminology. Second, I'm hunting for missing steps. I want to see a clear, sequential process. Sender, transmission, receiver. And third, and honestly most importantly, I'm looking for context. If there is no context, I simply cannot give you full marks. You have to anchor your reasoning back to the scenario, whether that's attendance data or a robotics factory. This is your concept to evidence to reasoning pipeline.
Now, think about the concept of real-world transfer. The exact same parity principles apply across banking systems, media processing, and secure communication. Showing these contextual links is the secret to remembering the consequences of choosing one error-checking method over another. Look, parity is simple and it's fast, but it completely fails with transposition errors or double-bit flips. Knowing why a bank might actually upgrade to using a checksum instead of simple parity shows that high-level, top-band understanding.
I need you to take a mental screenshot of this checklist right now. Seriously, burn this into your memory. This pre-exam parity defense checklist is your ultimate survival plan for literally any communication and internet question. 1. Identify the exact requirement of the task. 2. Classify the relevant data or hardware. 3. Explain the process in a logical sequence. 4. Check your context connection. Did you actually mention the scenario in your final sentence? If you follow these 4 steps, those parity marks are fully secured.
So, you've secured your parity marks. That is a massive win. But what happens when you turn to page 5 of the exam and the paper demands a full evaluation of a broader security method? Knowing parity is great, but leaving right now means missing the exact framework needed for those massive 6 or 8 mark evaluation questions. You need to know how to structure a complex evaluation, or you're inevitably going to hit a glass ceiling on your final grade.
Your mock survival plan continues next. You absolutely must master the evaluation framework to secure those top bands. Dive into our next explainer on the left now and subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. The mark scheme is waiting. Are you going to dictate the terms of your final grade, or will you let generic answers hold you back?